show that the Fourier series representation for the function here f of x is equal to the piecewise a 1 0, and if f of x is equals to 1, then our function, if x is between 0 and pi, then the function is 1, and x is between this x is between pi and 2pi, then function f is 0. Is here the Fourier's representation is given as this one: f of x is equals to 1 over 2 plus 2 over pi, the summation of sine 2n minus 1 x over 2n minus 1. From n is equals to 1 to infinity, you can show this one. How we show the Fourier series of this function f gives this f of x. Here is solution that we can use the Fourier series representation as f of x is equals to a naught plus here a naught plus summation of a n cos nx plus b n sine of nx from n is equals to 1 to infinity. Then where this a naught is given as this one: 1 over 2 pi integration of negative infinity to infinity f of x dx, where f is equals to 1. Here f is equals to 1 for x is between 0 and pi, and otherwise is 0. Then we can solve as here the integration 1 over 2 pi integration from 0 to pi, f of x is 1 times dx, then which gives that 1 over 2 pi, the integration of 1 dx is x from 0 to pi, here 0 to pi. Then here you can get the value that indicates is 1 over 2 pi times 1 pi minus 0. Then then you can get here the value is equals to pi minus 0 is pi times 1 over 2 pi is pi is cancelled by pi. Then you can get 1 over 2 only, and here is can say this a naught is equals to 1 over 2, and again here to find again an can use the equation here: 1 over pi integration from negative infinity to infinity of x cos nx dx, and you can substitute f of x is 1 from 0 to 1 times cos n is only cos n x, then can get this value, and 1 over pi integration from 0 to pi, because our domain is between 0 and pi, here which is equals to the integration for cos nx is can use chain rule, and here is nx, the derivative of nx with respect to x is here n, and you can out here can get 1 over n times sine of nx is the integration value for cos nx, and here is the coefficient, here is 1 over pi as it is, and from 0 to pi. Then finally you can get here can n times pi is here into sine of nx, then you can substitute pi to here and minus 0 to here, sine n pi minus sine 0, then this gives that this gives sine of n pi is here, n is here, or n is an element of integer integer, then you can say n is 1, 2, 3, 4, 5, then sign of n pi's are 0, 0, and here sign 0 is 0, 0 minus 0 is 0, then 0 over 0 is 0 times this value is gives 0. Therefore, an is equals to what? 0, 0. Again, you can get here bn. Bn is also 1 over pi integration of 0 to pi. Here f of x is 1 times sine x is only sine nx dx. Then the integration is formed as here 1 over pi. The integration for this one is, you can say, negative 1 over n cos nx, because the derivative of this one is sine nx from 0 to pi. Then you can make the product this one, and you can get here minus 1 over n pi into cos n pi minus cos 0, because this negative 1 over n is out here, and you can use only cos nx and inserting these values here. Then you can get minus 1 over n pi into here. If you can substitute 1 cos, here our n is 1 cos pi. Cos pi is here, can get cos pi is here, you can get minus 1, and minus 1, here is cos 0 is 1, minus 1 minus 0, minus 1, and here is 1, then minus 1 minus 1. If n is 2 pi, cos 2 pi is 1, minus, here is cos 0 is 1. If n is 3, cos 3 pi is negative 1, minus 1 here. If n is odd, here n is odd, n is 1, n is 3, and so on. Then here is, if n is odd, it is a negative. It is n is even, then it is positive. Then you can write as here cos n pi is negative 1 the power of n minus 1 indicate cos 0. Then you can write this expression as in the form of here, if it is this one is equals to 0 for n is what? N is even. If our n is even, then minus 1 the power of even is 1, 1 minus 1 is 0. Or here our n is odd, then change it into 2 over n pi, because here if you substitute negative 1 and negative 1 is negative 2, negative 2 times negative 1 is positive 2 over n pi, then n is odd. And after you substitute these values into the Fourier series representation, can get here, substitute into the equation of the Fourier like this one, f of x is equals to a naught plus this one. Then here you can get here a naught is 1 over 2 time plus here plus the summation of a naught is here, this one is 0, and the value for this one is only here, this one, and 2 over 2n minus 1 pi sine 2n minus 1 x. That indicates you can change this one. N is even, 0, n is odd, this one can get him. Then here you represent this one 0 if n is even, then here you can change into what? If your n is changed to here, our n is equal to 1, 2, 3, then you can say 2n minus 1 is the value you substitute here, and finally you can get 1 over 2 plus 2 over pi summation of sine 2n minus 1 x over 2n minus 1 for n is 1 to infinitive. But here finally you can add here this idea: if n is even, then 2n, and if n is odd, can change into n is integer. Here changing here odd to integer as like 2n minus 1, because n is starts from 1. If n starts from 0, then you can say 2n plus 1, but here n is start from positive 1, then you can write as n 2n minus 1 is as the changing value. Then you can say f of x is equals to this one is the Fourier series representation of this one. If you have any question, raise your hand.